Hello and welcome to our first hands-on session. In this session, I'm going to take the chance to help you get better oriented with some of the tools that we're going to use as we approach our business case with a programmatic and code-based analytical tool set. Now, before we jump in, I want to make sure that you have taken the opportunity to complete some of the prerequisite tasks that we talked about in some of our previous videos. There's three really important things that I need you to have done before we can kind of jump in and be on the same page. The first one is I need you to make sure that you have installed R, the language, onto whatever computer you're going to use as you follow along with this analysis. In addition to the R language, I also need you to make sure that you have installed RStudio. RStudio, we talked about it a little bit in some of our previous videos, is what's called an integrated development environment, or an IDE. Stated more simply, it's just a collection of tools in a single application that help us write our code more effectively. So make sure that you've got that installed as well. There's a free and open source version, and that's more than enough than what we'll be using over the course of our time together. So that's perfectly sufficient. And the third thing that I need you to do is to ensure that you've downloaded the sample data set to the computer that you're going to use so that we can move it into a project folder as we're starting to do that analysis. That'll be really important when we start to actually write code that treats this data set. If we don't know where it is, or if we put it in a location where it might get moved later on, that can create some problems for us. So let's actually start with that data set piece. If you've already downloaded it onto your computer, that's great, but let's actually create a project folder and move that file into the project folder. So I'm just going to start by opening up my documents folder, and this is just the home directory. It's just off of the home directory in most Windows machines. If you're on a Mac, you also have a documents folder. I would recommend that you go ahead and create this project folder under that same location. There's a few different ways we can do this. I think it's just as easy to right-click, come up to this new section, and then hit new folder. And we're going to give this a descriptive name that will help us ensure that we're in the right place as we're working with our data. So given that our business case deals with a suture manufacturer, and given that we are working with not just sutures, but sutures in a quality case, I'm going to go ahead and title this folder Suture Quality Analysis. And once I've got that folder, I'm going to double click into it. It should be empty, and I'll identify the location of wherever I stored the data set that I downloaded. In my case, that's in my downloads folder, and I'm just going to drag that over into this new folder I've created, and I should see suture defect data.csv. Once I've got that stored in this file path, I should be in pretty good shape, and we're going to go ahead and jump right in. Now, coming back to a slide that you have probably already seen, this is a really simple introduction to what RStudio is going to look like the first time you open it. It's divided into a couple different sections. I think that these are generally referred to as panes, like a pane of glass. We can see in the top right-hand corner, we have this environment history pane. In the bottom right-hand corner, we have a pane with a couple tabs. So we see files, plots, packages, etc. And then on the left-hand side, we have a console. And that console is where most of our code will actually be executed. Now, the big difference that you'll notice once we actually jump into this is when we create a new file, a new script where we're actually going to start to write our code, that typically will occupy this top left-hand section. So even though only 3 panes are visualized here, it's very probable that you're going to end up looking at 4 panes when you get into the actual working environment. Once you have all of those things downloaded and you have that data file stored in the appropriate directory, let's go ahead and launch RStudio and see what it looks like. So I've already launched it. I'm just going to bring it up here. You'll notice that it looks very, very similar to that picture I just showed you. There's one small difference in my case, and that is that I've applied a custom theme to make it a little bit easier on my eyes. If you're really interested in doing that, you can do that as well. You actually do that by coming up to this Tools tab, coming into the Global Options section, and then in the Appearance subset here on this left-hand menu, there's a bunch of different themes that you can pick from. I really like the Cobalt theme. It doesn't matter what theme you pick. You can leave it as its default. The functionality of the software will be identical. The only thing we're doing is changing some of the visual appearances here. I just cover that to make sure that if you're alarmed to see so much blue, you know why that's happening. So I gave you a little bit of an intro into these 4 panes, but I want to start by going into a little bit more depth. So I mentioned in the top right-hand side, we have this environment section. As we're working with our code, we're very likely to create variables, potentially create tables, lists of objects, all kinds of things. And anything that we create is actually going to end up being stored here in this environment section. It makes it easy for us to quickly reference that when we're typing the code. So let's say that we store a series of variables in something called vector1. If I want to take the average of everything that's in that vector, I can do that and I'll remember what that vector is titled because it'll show up right here. As we sit down and actually write some practice code here in a few minutes, you'll see exactly what I'm talking about. The history tab just keeps a running history of all of the commands that you have executed on your machine. I was doing some work previously in a different project, so you can see some of those commands here. Don't stress too much if some of these aren't familiar to you. That's at an unrelated project, etc. And there's an opportunity to connect to databases and Git repositories and plenty of other things. And finally, this tutorial tab can put you in a position to learn some of the basics if you're interested. So I usually like to leave it in the environment section because that's what's most helpful to me as I'm coding. And you can do that and start to navigate around a little bit as appropriate. Coming down to this bottom right-hand pane, we can see a few things. Right off the bat, we should actually see something that looks very familiar to us. This Files tab in this bottom right-hand pane is a window into our computer's file system. And as we look, we'll notice that I'm actually looking by default at my Documents folder. That's precisely why I asked you to create the project folder in your Documents directory. So we'll notice actually that that suture quality analysis is already here. And I can click into this just as if I was in the File Explorer, and I'll see that that suture defect data file is located right here. Now, if you get into a folder and you want to come back out, there's these 2 little dots. That's a carryover from the change directory command in Linux. You can click on that and it will actually take you 1 step back out into your directory tree. And here we are back in our Documents folder. Now, there's a couple other tabs here. One that will be pretty important to us as we go along is this Packages tab. R is really, really powerful. And one of the reasons it's so powerful is because there is an adamant user base who does a lot of collaboration. So many of these users will actually build what are called packages. It's essentially some add-on software that you can install very easily, and I'll show you how to do that in a few minutes here, to extend the functionality of base R. This can make really complicated things very, very simple by importing a package. So if you want to, you can actually install new packages right here from this graphical user interface. You would just type in the name of your package and hit install. Alternatively, you can do some package management, update the different packages, or if you want to, before we can use a package, we actually have to load it. Clicking this checks box will load a package for us. Now, in addition to that, there's this help tab, which can be really, really helpful if you're trying to find different things. You'll notice here that it's giving us some information about the install packages function. You can type in any function here and you'll start to learn a little bit more about it from help, and it actually gives you some examples of how to use those packages. So that's potentially really, really powerful. Some things in R can generate automatic previews. That's what happens in this viewer tab. And this plot tab, depending on your workflow, is where any graphics that you produce will be displayed, and then you can export them from here and interact with them in different ways. So to start, it makes sense to leave this in our Files tab, and we'll move on to one of the other panes. Looking at this left-hand pane, it will ultimately become the bottom left-hand pane, but for now it's kind of occupying the left half of our screen. It has 3 different tabs by default. The first one is a console, and if you're familiar with any kind of Unix-based programming, this is very similar to an interpreter. So I can actually type a little bit of code in here right away. So I'm just going to take 12 times 2 and hit enter, and you'll notice that it gives me an answer immediately. So this is where your code will actually be evaluated or executed. There's a terminal here, which we can sometimes use for system-based commands. These are no longer just R-specific. You'll notice that this prompt looks very similar to the command line prompt or the terminal if you're on a Unix-based system. And then jobs, sometimes as you're executing jobs, things can be scheduled or run locally or run on a server, etc. That's a little bit more of an advanced feature that we're not likely to get into during our time together. let's come back to that console tab. It's usually the default that I leave it at because I can check to see how code is running as I'm writing it. And let's open up our very first file. Now, I want to open up a file. It's going to start by being totally blank, and you'll notice that there's actually a bunch of different kinds of files that can be written in RStudio. RStudio is not just an IDE for R. You can write SQL, Python, CSS, JavaScript, C, C++. You can write many, many things here in RStudio, and it's a really powerful collection of tools. Now, in this little demo, we're actually just going to focus on R, and we have a couple different things here that we notice. An R script is basically just a plain text file that executes from the top all the way down to the bottom. And R notebook and R Markdown are very similar. I'll show you an example of those because that's what we're actually going to code in later. R can actually be used to build full-fledged web applications, and this is really powerful for dashboarding and things like that. Basically, any analysis that you can do, you can write in such a way and publish to a server so that it becomes a user-facing web app. You can also use R to build custom APIs for any kind of modeling work or application development that you do. It's a very powerful tool. There's a lot to get into, but we are just going to focus on the basics today. So let's, again, come up to File, New File, and select R Markdown. Now, as soon as we select that, we're prompted to specify some information about our file. You'll notice that we have some of those same things we can select. We have a Shiny app that we can build. That's the web application that I was talking about. But perhaps more interestingly, we can also create presentation slides directly in RStudio that run code and execute code in near real time. And we can also build documents. We're going to build a document together today. There are different output formats that we can select. The one that's most easy to publish and perhaps most easy to read is just an HTML file. Just about any computer these days has a web browser and therefore can read an HTML file even if it's hosted locally. So let's start by making sure that the HTML radio button is selected and make sure that the author is reflective of your name, and then let's go ahead and include a title to this document. Now, ultimately, we're probably going to build towards that defect analysis that we were talking about in our business case. So I'm just going to call this suture defect analysis. I'm going to hit OK. And you'll notice that automatically RStudio creates this fourth pane for us, and it kind of squishes down the console pane that we were talking about. If you want to resize those windows, you can do that by hovering over this little bar, waiting for the cursor to change into the four-pointed arrow, and then moving that around. That also works on the left to right axis as well, just as an additional tip there. But let's take a look at the anatomy of this R Markdown file. We kind of have a header, and then we notice that we sort of have these funny little sections. They're called chunks of what appears to be something similar to Excel functions or Excel equations. And then we have something that looks more like plain text. And finally, we have something that maybe is unfamiliar. We're not really sure what's happening there. So let's talk about why R Markdown is so interesting. And I think maybe the easiest way to do that is to go ahead and do what's called knitting this file together. That's basically compiling or publishing this file. So I'm going to click on the knit button. The first thing, and just again, that's located right here on the top left-hand side. The first thing that it's going to do is prompt us to save our document somewhere because it knows that it hasn't been saved yet, and so it can't run. We're going to come into our suture quality analysis folder that we created at the beginning of the video, and we're going to give this some kind of title. So I'm just going to go with suture defect, and I'm actually going to borrow that and suture defect analysis. And I'm going to hit save. And as soon as I hit save, you'll notice that our bottom left-hand pane changed. We got this R Markdown tab that popped up and gave us some information about how successful it was compiling that document. And you'll notice that it created an output file for us and then created an HTML file for us. So if we come back to our file system, we'll notice that we actually have three files. We have the defect data that we copied in ourselves. We have the RMD or R Markdown file that we just created. And in knitting the file or compiling the file, we also created this HTML file. Now, if I bring this over, you'll notice that R kind of automatically produced this little HTML document for us. And you might notice a few things. So let's actually kind of compare this to the raw code. What do you notice about the double hash sign or the double pound sign? You can see that that's creating some kind of header, some kind of special title. What do you notice about these code chunks? I think perhaps the first thing that jumps to my mind is we see that there's actually output associated with them. If we click over here to the plot section, we actually see that a plot was drawn, and that's pretty interesting. Now, this is exactly why I like R Markdown so much. It gives us a really clean way to integrate simple formatting, explanatory text or prose, and interactive code. It's great for report writing, and it's great for sharing your code. Even when I'm writing an analysis that potentially has an output that won't exist in any kind of visual format, let's say that I'm building a model, like a regression model, I still code that particular analysis in R Markdown because it provides a really easy way for me to document my code as I'm writing it, to make sure that if I hand it to another one of my team members, that they will be in a position to capture it, and to make sure that if I need to review the code I wrote in 1, 3, 6 months, I'm still in a position to understand what I was trying to accomplish with each task or with each code chunk. So it's a really great format. You can also click this little button to open it in a browser, and you'll see that that just opens it up in a regular old browser. The browser I happen to be using in this case is, the Chromium-based version of Microsoft Edge, but you could open it in Chrome or Safari or anything that can read HTML documents. And this is really, really powerful. It's a format that I really like and I think is very, very effective for some of the reasons that I just discussed. So let's close this out and learn a little bit more about how it functions. Now, I noted that this double hash sign creates some sort of title. And for those of you who are familiar with HTML, you might already be familiar with Markdown. This is just a variant of Markdown that's written in such a way to accommodate our code. All Markdown does is give me a way to really simply specify in plain text what I want an HTML or a website interpreter to do. So I just added a couple extra hashes in front of this R Markdown. Let's knit this file one more time and see how that changes. Yeah, you'll notice that it's quite a bit smaller. That's because a hash sign is representative of a level header. So a 2 hash sign symbol in front of a particular text specifies that I want what's called an H2 or a level 2 header. If I were to bring it down to just 1, let's see what happens. You'll notice that it's even bigger than before. Including plots is another H2. And you'll notice that our Markdown, because it is now specified as an H1, is bigger still. You can also see that we have the ability to include links, that we can sometimes include little individual sections of code. I'm just going to modify that really quickly and show you what that looks like. Now the key I just pushed there is the key that's shared with the tilde. It's right above the tab key on the left-hand side of your keyboard. And you'll notice that it kind of creates this inline code snippet. That can be really helpful if you're referencing a function in some of your documentation or something along those lines. So that probably puts us in a position to understand some of the basics of our Markdown. There's a couple other things to note. So the first one is that if I come up to this help section and click on this Markdown quick reference, you'll notice that our help tab, our help pane rather, has pre-populated with some information around how to use our Markdown. So right off the bat, we can see what I just told you about with the headers. We can see how to add italics and bold text. One that I do think is actually particularly useful is we can see how lists are managed. So these are like bulleted lists. And this can be a really useful guide because you can actually just copy and paste information directly out of there, paste it in here, and then you'll notice that this puts us in a position where we can actually start to use these items in our write-up. It doesn't have to say item 2. We could say, insert item here. And let's go ahead and knit that one more time and observe what happens as it's processed. Right there, you can see that I was able to generate an unordered list, meaning one that just contains bullets, doesn't specify a sequence, and an ordered list right below. You'll notice that ordered list has a sequence to it, so it's 1, 2, 3, etc. And this is a really, really simple way to get some quick help if you're trying to solve a formatting problem in R Markdown and move on as a result. Now, there's a couple things that we haven't talked about yet, and that is these code chunks. Now, code chunks are what we need to do in order to tell RStudio that this is not plain text, it's not prose. This is how we signal that we want this code to be executed or evaluated. So we'll talk about how to create a code chunk here in a second, but before we do that, I'm actually just going to come over here. It's a little bit small, but you'll notice there's 3 buttons on the top right-hand side of this code chunk. And this one on the far right says Run Current Code Chunk. And if I click on that, there was a little green bar that flashed right here. Watch for that, and I'll click one more time. And that is the process indicator, or rather progress indicator, letting us know that that's the line of code that's being run, and then we see the output of that code directly below it. Now that output actually matches what we were observing in the compiled HTML file, which is really helpful because that means that if I'm writing code, I don't actually need to write some code and then hit knit and wait for the R Markdown engine to compile my document and then come see and examine it and then maybe jump back into this and try to make some additional changes. I can actually make changes in near real time by, say, specifying a column. I'm going to say that I only want to look at the speed column. And I'm going to run that code chunk again, and you'll notice the format's a teeny bit different, but the information is exactly the same. And I can just keep running this code block over and over again until I have written and refined the code that I need for my analysis. So it's a really, really powerful tool. Now, sometimes you might write code that requires a sequence. A really simple example of this is importing data, maybe in a code chunk that's on line 37, and then coming down to do some analysis for it later. And if I need to refresh my analysis up to a certain point, I can actually click this second button from the right, and this runs all of the code chunks up to my current chunk and then stops. So you'll notice that if we watch for that green indicator over here on the left, it's not going to show up for line 46, but it will show up for line 38. So let's do that right now. You saw that it ran, we saw that nothing happened here, but I'm now certain that all of my code chunks previously written in my document have been executed and are up to date, and I can now run my current code chunk and observe my output. So this is a really efficient way to write code. It's a really great way to process information in kind of an iterative way where you can sort of bounce back and forth between 2 or 3 code chunks and get the output that you desire. Now there's one last button here, and this is the little settings cog. And let's go ahead and knit this document one more time and take a look at the output and then explore the settings cog. What do you notice about the summary code chunk in our R Markdown finalized HTML file? How is it different than this code chunk right here, the plot code chunk? When I look at the RMD file, or I guess it's actually the HTML file, I can see the code that generated this output for the summary. That's not true for the plot. I can't see the code that generated this output. Now, if we look back over the code, we might notice a difference between these 2 elements, and that is that for the plot code chunk, we actually have this extra flag telling us that echo has been set to false. Echo is RStudio's way of echoing out the code and surfacing it to the user. So if echo is set to false, then the code is hidden. If we set echo to true and do this again, I'm just going to hit that knit button one more time, we should now see the generating code be displayed to the end user. Now, most of the time when you're writing a document for yourself, you want to see the code. That's why you're the analyst. You want that level of granularity and you want to understand what's happening. But if you're building a report, this code can actually be quite distracting for someone who doesn't understand how to write code, or even if they do and they just want to focus on the results, it might be best practice to actually set echo to false and to hide that information. Now, that's something that you can decide yourself. It's totally up to you based off of the workflow that you're building. But I would say that as a general rule, if you are authoring an R Markdown document for consumption by someone else, uh, before you finalize it and send it to them, you should set the majority of your code chunks to echo equals false so that that information is not distracting your user when they're trying to process your report. Now, if you click on this cog, you can actually do lots of those other things. Like you'll notice I have show code and output, show output only, show nothing and don't run the code. Changing those options is what is going to set echo and other flags to different values. So there's quite a bit that you can do with this. You can suppress warnings, you can suppress messages, you can do all kinds of things. And you can do it either by remembering some of those flags and typing them out yourself, or by clicking this little cog icon and selecting whatever is most appropriate. So now that we've kind of gotten into the basics of an R Markdown file and why it's such a powerful tool, I actually want to start from scratch. So you notice that RStudio kind of generated this for us. Most of the time, I actually start by deleting all of that information out, but I let RStudio kind of generate the header for me and this initial setup chunk. We're not going to go into what this means in this particular case, but you'll notice that that echo flag is popping up again. So don't stress about this particular thing. It's basically something that sets some of the parameters of our subsequent chunks automatically, but we don't need to worry about it for our introductory course. That's perhaps maybe more of an advanced feature. So before we get started, there's a few things that we need to do. And I kind of mentioned that one of the first things we should do is create this project folder so that we have a shared environment for our code and our data files and everything else. And that is really important. We created that, but we now need to tell R that that is the first place that it should look for any file that we reference, etc. And there's quite a few different ways to do this. What we're doing is called setting the working directory. A directory is another name for a folder. So we're basically telling R what folder we're going to do our work in. Now, there's some ways that you can do this in code. I think when you're first starting out, maybe the easiest way to do that is actually to come up to this session file menu item, come down to set working directory, and then to choose directory. That's a good way to do it, but one of the challenges that we face if we do that is that when we're rerunning our code over and over and over again, we really want to try to script things or write them down and express them in code rather than relying on a user to click buttons in a graphical user interface, because that is not repeatable. So while it's perfectly valid, especially when you're not really doing, when you're not really writing code that's going to be scheduled and run automatically, to come up here to the session tab, go down to the working directory and then choose the directory, and then that will kind of prompt the regular file viewer that you're used to from using your computer, and you can kind of pick a directory from there. I mean, this is very, very normal user interface interactions with your computer. We instead are going to express this via code. And probably the easiest way to do that is to put your cursor on a new line and to press a keyboard shortcut. You'll notice that if I didn't have a keyboard shortcut, I'd be obligated to type that tilde key 3 times and then to do an opening curly bracket, type R, push return after that bracket, and then type another 3 of those tilde symbols. That's pretty laborious and not very efficient. So RStudio is our friend here. And if we push on a Windows machine, Control, Alt, and I, it automatically generates that code chunk format and places our cursor right in the middle. On a Mac, you can do the exact same thing with Option Command I. And then all we need to do is specify the working directory that we want. So we're going to use our first function here. If you're familiar with Excel formulas, it's very similar. That function is just set WD for set working directory. And we can kind of type that in, and if we wanted to, we could highlight that function. I'm just going to copy it. So, I highlighted it, pushed Control C. I'm going to come over to the Help tab here, and I'm going to run a search for that particular item. And you'll notice that it says, okay, I think you're looking for something related to getting or setting the working directory. And there's a function set called getWD that will help you do this. And you'll notice that we can see some information about this right off the bat. So we might actually start by running getWD. That's an interesting approach. This is going to tell us where our current working directory is. You'll notice that I've already set mine in prep for this video, but your current working directory might actually just be the documents folder or something of that nature. So using the getWD command will tell you what your current working directory is. If I change this to set working directory, you'll notice that this function takes a single argument, and that argument is the directory expressed as a character string. So we also see that expressed right here, so I can actually just copy and paste this in. And if I run this code, it has just set my working directory for me. If I come over to the File tab, and I come to the More section, I can say, hey, go to the working directory, and it should prompt us right into this folder here. So now we're in a situation where if I wanted to read this Excel, or I guess it's a CSV file, I no longer have to type C:/users/username/documents. I can actually just say, hey, read suture_defect_data, because I've already told the system what directory folder to look into. Now, one thing to note, experienced Windows users might notice that backslash, this forward slash is kind of foreign. Most of the directory paths that we're used to in a Windows environment actually use this key instead. And that is just an unfortunate side effect of most programming languages, or at the very least R, being written for a Linux-based environment where they use forward slashes. So if you copy and paste a file path from your system and you notice that it is using these backslashes, you'll need to go in and manually replace those with forward slashes. Now, we've kind of gotten into the weeds a little bit here on even just setting a working directory, but it's really important to get some of those things right the first time so that it's easier for us to write our code going forward. Now, there's really just two major things that I want to do before we wrap up this video. And that is, I want to show you how to install packages, kind of those software add-ons. And then I want to show you some of the basic operations that we can complete in R to do basic arithmetic. It's a really good introduction to coding in R. And it's actually something that we do all the time when we're working with data. So we can delve into those issues once we get into the basic operations section. But let's first talk a little bit about package management. So I mentioned that packages are a way to extend the functionality of what you're trying to do in R. One of the easiest ways to install packages could be to come over here to the Packages tab, hit the installation button, and type in the thing that you're interested in. But again, because we prefer repeatability, we're actually going to do that in code. And I can do that with the install packages command. So you'll notice that, let's actually take a couple steps back. You'll notice that I bring up a new code chunk by holding Control, Alt, and I. That puts my cursor right in the middle of that code chunk. And then I'm going to start typing the name of the command or the function that I want to use. And in this case, it's install.packages. If I wanted some more information about install packages, I could do what we saw earlier in the Help tab and just search for install packages. And that would give us some information about it. I see that it's a utility, install packages. If I click in there, I get that same help page that we were looking at earlier. So back to the code portion, you'll notice that as soon as I give R a good enough idea of what I'm trying to do, it starts to recommend some functions. Be careful with this. Auto-completion is really helpful, but it can also lead you down the wrong path a few times. I want install packages, not this other option. So I'm just going to click on that, and you'll notice that it sort of completes the function with open and closing parentheses and then places my cursor right in the middle. I'm now just going to specify the name of the package that I want to install. So because this accepts packages as a string, I need to put it in quotes. So I just pushed Shift and the quote mark button. The thing that's really great about RStudio is it is auto-completing even that for me. So I'm just going to go ahead and actually zoom in a little bit so that you can see maybe my code a little bit more clearly. If I hold down Shift and push that quote button, it gives me both an open and a closing quote. and places my cursor right in the middle. I'm then going to type the name of the package that I want to install. You should do this. This is a great package. It's called the Tidyverse. And then I'm going to click Run. And as we watch, we can actually see that we're going to start to do some things down here in the console. Now, you'll notice that we get this warning telling us about our tools not being installed. That's fine. There's more than one way to install packages, and we're just using the default method, which is to go and look at a CRAN repository. That's, I think it stands for the Centralized Repository of Applications in R or something of this nature. The point being that we, more importantly, got this confirmation that the package was successfully unpacked. It did a checksum, and we can see that the packages were stored on our local system. That gives us the ability to start using that package without any problems. But I mentioned that we need to do two things. Not only did we need to install it, but we also need to load the package. R makes this distinction because you can see that even in just my daily workflow, there's a lot of different packages that I've got here. If R loaded them all every single time, the system would be pretty slow. And there are some packages that actually have the same function names, and so things could get pretty hectic. So now that I've got it installed, I'm actually just going to push return and come down to the next line and type the command library and then type in tidyverse. You'll notice this one doesn't necessarily take quotes. If I were to run this code chunk, I would prompt the installation again and then do the loading function. So I'm actually just going to do what's called commenting out a line of code. If you want to annotate your code, you can do this by putting in a hash symbol. That's Shift-3, and then I can type a useful comment here, and that's a great way to sort of annotate your code. Another thing you can do with this, though, is if you have a particular line of code that you don't want to run, you just put a hash sign right in front of it. And now, when I run this chunk of code, it will ignore line 17 and treat it just as an annotation, and then actually execute line 19. So let's go ahead and do that now. You'll notice that it's taking a little bit of time, and it runs. We also notice that this particular package does a few things. One, it attaches a collection of helpful supporting packages. And two, it spells out some instances where we had functions that had the same name. You'll notice that it's saying, hey, there's this function called filter as part of the dplyr package that is masking or overriding the stats filter package. It then gives you this useful format where if I want to use the stats package, I can't just say filter, I have to say stats : filter. But that is how you load a package, and it's one of the key ways that we will get things done in a really powerful and simple way with R and RStudio. So I'm just going to create a couple extra lines for us, and we're actually going to move into some basic operations in R now. Now, the first thing that I want to show you, and I kind of already alluded to this when I showed you the console, you can treat R code exactly like a calculator. And you can just type in basic mathematical operations and it will evaluate those and give you an output pretty easily. That's helpful, but if we were going to do our statistical analysis that way, we would have to type a lot of numbers. So R gives us another tool that's actually very, very helpful, and that is the ability to create variables and objects and assign things to them. So I'm going to start just by creating the variable x. That should be very familiar from your algebra days. And I'm going to assign it a value. So the way that we do that in R is a little bit less intuitive. You might have thought of doing something like x equals 12. And you can do that. That works. You'll notice that our environment variable, our environment pane got updated with its first variable pairing. The equal sign, for whatever reason, is not how most programmers in R actually assign things. That's largely because the equal sign is used sometimes in logical expressions to do like, is value A equal to value B? And for that and perhaps some other reasons that I'm not aware of, the community prefers to use this little arrow symbol to assign something. So let's actually change that to 15. So you'll notice that that's just the less than sign. You can get to that one by typing shift comma, and then it's a hyphen sign, and you can get to that one by typing the hyphen symbol that is just to the right of the 0 key on the top of your keyboard. Now if I execute this, you can see that it was successful. It updated the value of x to 15. You'll also notice that it overwrote it. We no longer have x equals 12 anywhere in our system. So this is really, really helpful, but you might kind of be a little annoyed with that. You might not really want to hold down the shift key to type this assignment operator every time you want to do something. And that is totally fine. Once again, RStudio is our friend and makes this very easy for us. If you hold down the Alt key, which is the key just to the left of your space bar, and then push that same hyphen key, it automatically types out the whole assignment operator and a space after it. So it can be a really easy way to, make assignments in an efficient way on the fly, rather than having to hold down the shift key and remember a couple different keys you need to press. It's just Alt hyphen, and it will auto-generate that for you. So let's learn a little bit about how R treats variables. So I've assigned a value to X. I can actually just go ahead and do basic math with this variable exactly as I was before. Now you might be noticing that in that instance, that little green bar only flashed on line 26. I can run my entire code block, or if I want to, I can run an individual line of code. And the way to do that is to select the line of code you want, or to put your cursor on that line, hold down the control key on a Windows machine and push enter, or if you're on a Mac, you would hold down the command key and push enter. Let me show you that in a slightly different way. So here I can basically accomplish the exact same arithmetic that I did up on line 26, but this time I'm not using a variable, it's explicit. Again, holding down control and pushing enter, I get that output. If I run the whole code block or code chunk, you'll notice I get the output twice. And that's just because R is evaluating line 26, showing us the output, and then evaluating line 28 and showing us the output. So that's a pretty powerful way that you could store a variable that was really important to you. I mean, let's say that in theory we wanted to, we were foundational in our geometry, we could assign a value to pi. And then we would have pi stored, and anytime we needed pi in the future, we could do something like pi times x. And that would put us in a position where we could start to evaluate all of these variables together. So lots of power there. R does something that's even more interesting to me, and that is that you can store more complicated object types. So in both of these instances, we stored a single value into a single variable, but we can also create vectors, which are like sequences of variables. And so I'm just going to create a vector. I'm going to call it VEC. I'm then going to hold down the Alt key and push that hyphen to get an assignment operator. And I actually have to use a new function here. It's called the combine function. It's really simple. It's probably one of the most foundational functions you'll use in R. It's just C. And then I do an open and closing parentheses, and I can type a sequence of values in here. I'm going to hold down Control and hit Enter to run just that line of code. And you'll notice that I now have over in my Environment tab something called vec. And it is a number. It is 1 through 5 spaces long. And it just so happens that the numbers we assigned also happen to be 1, 2, 3, 4, 5. So that's a really powerful way to be able to start interacting with rows of data or columns of data. We can do this, accomplish the same thing with a little bit of shorthand, and that's this colon. If we go C, a certain value, colon, and then a value that is later in that sequence, and hit enter, you'll notice that it automatically generates that for us. Now, it might not have looked like much of a change, so let's actually do that with 10 here. And you'll see that I'm really quickly able to generate a vector with 10 values in it. Now, just like we can do arithmetic with variables, we can also do arithmetic with vectors. So I'm going to go ahead and multiply that vector by 2. And watch the output that it gives us. What do you notice about how R is performing this multiplication? Depending on your previous experience, you might have expected R to go through a certain order of operations. I'm not saying that it's necessarily correct, but there's no reason necessarily that R couldn't have summed together that entire vector and then multiplied it by 2 and given you a single answer. R doesn't work that way because this unlocks the ability to perform operations, meaning like multiplication, division, etc., in a vectorized way, meaning that I'm going to take my constant, in this case 2, and I'm going to perform the operation. We specified the asterisk, that's shorthand for multiply, and then I'm going to multiply my constant by each individual item in that sequence. So that's why we get 2, 4, 6. If we run this code chunk together, we can actually, I'm just going to call vector one more time so that we can get the output there. If I run this code chunk together, you can actually see that R is multiplying each individual value by 2 as it goes along. And that's really, really important when we start to work with tabular data, which is pretty common in most data analysis roles. So be prepared for that. But that concludes our introductory session on sort of basic operations and a tour of RStudio. I hope that this has been informative. In the next section, we're actually going to start our analysis. And so that will be a little bit more engaging. And that's where we'll actually address some of the questions that we specified in our business case. But this hopefully helped you get a little bit more comfortable with the tool and put you in a position that as we go through our next hands-on session, you're better prepared to follow step by step. Thanks for joining, and I'll see you guys in the next video. Take care.